Hello everyone, this is Yuan. Today I'll present our paper to explain or not to explain, a study on the necessity of explanation for autonomous vehicles. Our paper won the Best Paper Award at TEA Workshop at NeurIPS 2022. This work is not possible without our awesome team, with SJ from Stanford, Yanlin from Apple, and my PhD mentor, Professor Drix Campbell at University of Illinois Urbana-Champaign. Before our presentation, we would like to express our great thankfulness to the program committee for recognizing our work and potentials. Expandable AI in the context of autonomous systems has drawn broad interest from researchers. Recent studies have found that providing explanation for autonomous vehicles' actions has many benefits. For example, increased calibrated trust and acceptance to the self-driving technology. However, prior work put little emphasis on when an explanation is needed, the degree of its explanation necessity is, and how the content of explanation changes with driving context. Meanwhile, the only public available explanation dataset for driving, the Berkeley Deep-Derived Explanation Dataset, may not be practical for training and deployment, which we will elaborate in the next slide. First, a brief introduction of BDDX dataset. This dataset contains videos captured by a dashcam mounted behind the front mirror of the vehicle. Along with the video data, the dataset also provides action description and justification on why, at a certain time, the driver makes such driving decisions. This dataset provides a nice training dataset for researchers to train models to log each of the self-driving decisions. However, one problem in BDDX is that it contains a large amount of action explanations without carrying much information to the passengers. For example, the first two highlighted actions. Thus, it motivates us to explore on what kind of explanation is necessary and how necessary it is to remind people in real time. With that, here are the main contributions in this paper. We conduct a preliminary user study around explanation necessity in self-driving vehicles. We present the first explanation necessity dataset with necessity score, justification, and timing per video clip. We demonstrate through our baseline model that real-time explanation necessity estimation from visual input is possible based on our dataset. Let's start by introducing our online user study. In this study, we are interested in testing the following two main hypotheses. Explanation and necessity is correlated with driver types and driving scenarios. The presence of explanation increases users' trust in autonomous vehicles. And the figure down below outlines the procedure of our user study. First, we conduct data collection over more than 1,000 video clips in BDDA dataset. For each video, we ask each of our 5 annotators to label when an explanation is needed and how necessary that explanation is needed, and provide one potential action explanation. And then we perform hierarchical clustering on the text explanation associated with each video clips to group all the video clips into 38 unique scenarios. In our user study, we randomized the scenario order and asked the participant to give their estimation of necessity score for each of the scenario explanation, and collect other information related to users' trust to the self-driving car, driver types, and explanation preference. And then we finally conclude our study by a post-study analysis. So here are more information about the user study. So for the participant background, there are 18 college student participants aging between 18 and 25 years old with driver license. And there are two manipulated variables. One is the driving scenario, which we previously introduced that we label by hierarchical clustering on the text video comments. And then we have driver types that can be either aggressive or cautious. Here we manually define those based on a set of rules. For example, if the participant report that they frequently changing lanes when they are driving on their own, then we label them as aggressive. Finally, for the dependent variables, there are more than two variables. One is the explanation necessity score for each video, which can be ranging from 0 to 1. Another variable is like the trust to self-driving cars degree, and this is measured in 1 to 10 Likert scale. Next, I'll introduce our main user study result. First, we run point by serial correlation analysis between explanation necessity score and driving scenarios. Here, to get binary label, we label each video clip as whether or not one scenario happens. Our table shows that there exists correlation, though not very strong relationship between variables. Near crash events is more necessary for explanation, but ordinary car decisions like slowing down at a stop sign or even pedestrian passing shows little need for explanations. In these slides, we're wondering what the sequence with the highest and least agreement on explanation necessity looks like. Thus, we extracted corresponding video sequences. The first row is the video sequence about a normal car following scenario in a traffic jam, and the second row is about a near crash scenario. Our finding is that people tend to agree on the near crash driving situations. On the other hand, for the ordinary scenarios, for example, driving smoothly on the highway, people's opinion on explanation necessity varies. Here are more quantitative findings. While participants express overall distrust on self-driven technology at the current stage, they show trust on the credibility of self-driving explanation. This finding suggests introducing right explanation content has the potential to influence people's trust in autonomous vehicles. Besides, we find driver types influence explanation necessity score. Specifically, aggressive drivers seem to think it is less necessary to have an explanation compared with the cautious driver on average. And finally, we noticed that the standard deviation of the explanation necessity for the same scenario varies a lot, which indicates personalization on explanation is desired. For the second contribution of our paper, we present the first explanation necessity dataset, which augments the existing Berkeley Deep Drive attention dataset. For each video clip, through our customized app, we asked our annotator to mark when to prompt an explanation, how necessary the explanation is, and what explanation should be look like. Each video clip is annotated 5 times from different people. Along with the original metadata in BDDA, for example, the driver attention data, driving speed, we provide exclamation moment, explanation necessity, and text explanation to augment the existing BDDA dataset. To demonstrate the usefulness of our dataset, we set up a spatial temporal RNN baseline model to estimate whether an explanation is necessary at a moment given previous RGB frames. We compare our model against random guess and evaluate on test AOC score. Our results demonstrate that the feasibility of explanation necessity inference in real time is possible, even though a higher capacity model are necessary to obtain better performance. Finally, here are the conclusion and takeaway of our paper. The need for explanation varies with driving scenario and passenger identities. People agree on explanation necessity more on near crash events, but hold different opinion for ordinary and anomalous driving situations. Finally, real-time explanation necessity inference is possible. Thanks for watching, and please check our paper for details.